we'll give it another minute or two here for people to get logged in, and then we'll get started here. All right. So first of all, thanks everybody for coming today. This is a better turnout than we've seen in the past couple weeks, so I'm glad to see that. Today we have Daniela Orjuela. Did I say that right? I probably butchered that.
Daniela, yeah, you're right.
She's going to be speaking to us about the work that she's doing with Dr. Camberato and Dr. Nielsen on starter fertilizer in corn. And so with that, Daniela, I'll turn it over to you. I just ask that people remain muted throughout the presentation, and there will be time for questions at the end.
Okay. So hello everyone. Thank you for coming to my presentation. And today I'm going to talk about corn growth and yield response to starter fertilizer. And so we can start by introducing what is starter fertilizer. So starter fertilizer is a small amount of fertilizer that is placed near or with the seed at planting time. So in this graph, we are seeing a specific placement that is 2 inches to a side and 2 inches below, or 5 by 5 centimeters, 5 centimeters. And this placement is important because we want to place the nutrients close to the seed, but without injuring the seed. So these allow the farmers to put a different amount of different nutrients close to the seed. The goal of the starter fertilizer is to enhance earlier uptake of nutrients like NPK, and earlier research has shown that these enhance the early season development. So here we have in the picture 2 different plots. The plot in the upper part is showing bigger plants as a response of the use of starter fertilizer versus the control plot that is in the lower part. We can see smaller plants and sometimes also a lighter green color in the leaves. So to know more about starter fertilizer and what these do in corn, we have some background information. And research that has been done here at Purdue in recent years has shown that the early growth is enhanced. And this enhanced is either by dry matter accumulation, a high dry matter accumulation, or an increase in height. Another result that has been usual and common in the starter treatments has been that starter plants with starter take less days to reach silking stages, meaning that need to accumulate less degree days to be able to reach reproductive stages. These less days to silking can be related with a decrease in grain moisture. So we will have a longer period of time for the grain to actually dry more. And in the case of yield, this response to starter fertilizer has been inconsistent. About 1/3 of the uh, trials that has been done here in Purdue has shown an increase in yield. So why we have this different effect in yield can be related with the type of tillage system and the rotation crop. So for our conditions, we have no-till system and continuous corn is our system. So then we go for a research question, and we want to know if a starter fertilizer different in composition, meaning that we have a N, P, and K starter fertilizer, will have a different effect in core growth, yield, and grain moisture, pretty much, was our main goal. And to answer this question, we developed a methodology. So we had two research sites. One was at NIPAC, that is Northeast, and Southeast, that is CPAC, here in Indiana. And these two research sites are large-scale field research or large plot scales. For our treatments, and as a control, we place a small amount of nitrogen per hectare. And for all our treatments, we put sulfur, about 8 kilograms per hectare of sulfur to avoid sulfur deficiency in all the sites. So our first nitrogen and starter treatment was only nitrogen. So we add about 34 kilograms per hectare of nitrogen. Our second starter treatment was the addition of phosphorus. So we have nitrogen plus 17 kilograms of P2O5 per hectare. And our last starter treatment was the MP plus potassium. So we add 11.5 kilograms of potassium per hectare. It is important to notice that when we did the sidedress, the nitrogen was applied to supply the same rate of total nitrogen to all treatment. This means that at the sidedress, we apply a higher rate of nitrogen to the control than to the starter treatments. To be able to develop our research and get our sampling points, our plots were 12 rows wide, and each row was separate 0.75 meters from each other. And to obtain yield and grain moisture, we use the 6 middle rows of each plot, and we harvest them. And there we use calibrated yield monitors in commercial combines to obtain yield and grain moisture. Across the season, we have different sampling dates. So the treatment placement that we used was 5 centimeters by 5. So 5 centimeters below the seed and 5 centimeters one side to the seed. And we use liquid fertilizer. So we use a total of four different fertilizers to supply all the treatments. For the data collection, we did earlier sampling. So we want to follow the growth stage and how the plants were growing in the dry matter accumulation across the season. So we sample around every 10 days in each plot, each field, to get data from around B4 to B12. And we collect and record the total number of collar leaves. And at each sampling date, we collect whole samples to be able to get dry matter accumulation and do the plant tissue analysis. After that, we moved to the R1 sampling. We did the recording of the plants that were already tasseling. We collect whole samples again, and we did dry matter and plant tissue nutrient amount. And at the end of the season, we did a data collection at harvest with the grain moisture and yield, and additionally, we took whole samples to get plant tissue nutrients. And so with that information, I want to open the results. And for this presentation, I'm going to present only results of 2019. We did the same at the two fields this year, but we have not analyzed that data. So for my first result of today, I'm going to present the number of color leaves at each side. So we have CPAC in the left side, and I think that you can see this. Yeah, we have CPAC here, and we are going to see the average number of color leaves in the y-axis versus the time after planting. And we calculate time after planting based on the growing degree days in Celsius degrees. For our treatments, control are going to be always the red diamonds. Nitrogen, only nitrogen starter is going to be the circle green. Nitrogen plus phosphorus is going to be the purple square, and NPK is going to be the blue triangle. So for the statistical analysis that we did analysis of variance per each site per each sampling date. So this is a sampling date. We have here another sampling date, and all was analyzed separately. So what we did was, if the analysis of variance was significant, meaning that the p-value was lower than 0.1, we will use an LSD test to separate the means and be able to notice if we had some difference. When we did that, we get to the finding that the means of the starter treatments never separate. So you can see how the means of the three starter treatments are always in top of each other. So we figured out that our first conclusion of the presentation is that the addition of phosphorus and potassium to the nitrogen or the first starter treatment did not show any difference for all the variables that we measured last year. So then what we did to compare the control versus starter was a single degree freedom contrast, where we calculate the average for the three starter treatments, and we compare that versus the control. So every time that you see a asterisk, that one is showing where that contrast was significant different. So that is to show just difference between control and starter. So with all that clear, we can start with the results. So for average number of leaves, we found that around after D6 for CPAC, we were able to detect a difference in the number of leaves. So here we will see that the starter treatment has around 0.5 more leaves than the control. And across the season, the plants keep growing, and this difference keep getting bigger. So at the end of our last sampling date for a average number of leaves, we found that the starter treatments will have around one more leaf than the control treatments. In the case of NIPAC, we have a similar trend, but we were not able to detect difference as early or as big in magnitude as with CPAC. So then at the end of the season, we will have around 0.5 to 1 leaf difference between the control and the starter. But this, we couldn't find any difference earlier in the season. So here what we found was that the use of a starter fertilizer in fact enhanced the early growth of corn in the addition of more leaves for the plants that has a starter fertilizer. Then we can move on to dry matter. So again, now we are going to see dry matter in the y-axis and average number of color leaves in the x-axis. So we want to know if that difference in number of leaves we could be able to detect it also with dry matter accumulation. So we in CPAC could detect a difference early in the season. So this graph is showing that around B6, the plants were accumulating dry matter differently. So plants with the starter fertilizer has had more dry matter accumulation than plants with control. And this difference keeps getting bigger and bigger across the season. And around B14, even though for the plants with the starter, we will have around 15 leaves, and the plants without the starter, the control B will be around 13 to 14 leaves, we will see a higher difference in dry matter accumulation. So this means that plants either are bigger, has more leaves, and can be taller. And this is an example of how we saw difference between control plots and starter plots in height of the plants. In the case of NIPAC, the data show a similar trend, but the difference were not as easy to detect as in CPAC. So here we did show difference in dry matter accumulation, but if you can see that the two lines are really close, this is suggesting that if this plant, the control plant, it reached at the same number of leaves, these plants will not be different in dry matter. So probably on NIPAC, this lower difference was related to a higher variability in the field, across the field. So again, the starter fertilizer increased the dry matter and for CPAC due to a more number of leaves, color leaves, and bigger plants. In the case of nutrient content and nutrient concentration, I'm going to present only the data of CPAC, because of time, but the data behave similar between the two fields. So we want to know how the concentration differ between the treatments, knowing that we were adding nitrogen or phosphorus or potassium to different treatments. But again, with the three different starter treatments, we didn't see any difference among them. So we did again the average of the three treatments and compare that with the control. And that is shown. That difference is shown by the asterisks. So in the case of nitrogen concentration first, we can see that at early stages, the plants with starter fertilizers, in fact, has a higher concentration. But when the plants keep growing, and we get to around B14 to B16 leaves, we detect that the plants with starter had a lower concentration of nitrogen. So here is the point where that behavior change, and here is the point where we put the siders. So we siders at B7, and you have to remember that we apply a higher rate of nitrogen to the control than to the starters at that point. So this could be this could be related to that application of nitrogen. So the controls had more nitrogen after siders, and they uptake and have more concentration at that point. And we have still to remember that these ones are going to have less leaves. In the case of content, we calculate nitrogen content based on concentration and dry matter accumulation. So for both treatments, the content increased across the season. And the difference that we can see here were related to dry matter accumulation, because this dry matter accumulation offset the difference in concentration. So in case of nitrogen concentration, we were able to say that this was lower in plants that were more advanced in number of leaves, meaning this has one more leaf compared with the control. In the case of phosphorus, and Thinking that we add phosphorus to 2 out of 3 starter treatments, we did not find any significant difference among the starter fertilizers. So putting phosphorus in the starter did not affect the phosphorus concentration in our research sites. So in the case of phosphorus, we see that after B6, the plant's concentration for both control and starter start decreasing, and this is a normal behavior with phosphorus due to the use of this in plant physiological processes. They are different, significantly different control versus a starter. So we will have control with a higher concentration of phosphorus, and again, different in leaf stage. So if we were at the same leaf stage, maybe we will be having a closer amount of phosphorus as concentration in that plant. In the case of content, were not able to detect any difference in the content of phosphorus, and that was again related with the concentration and with the dry matter accumulation in each plant, control versus starter. In the case of potassium, we saw for the both treatments or all the treatments, the trend was the same. The potassium concentration decreased across the season. And at the end, we were able only to detect a difference around B14, but this was related with a difference in leaf number more than the amount of potassium being uptake. And for content, we could detect difference but early in the season around B8. And this again is an effect of the different dry matter accumulation for the different treatments. So now with the last data that I'm going to present, I'm going to present tasseling, grain yield data, and moisture of the two sites. So again, remember that we didn't find any difference among starter treatments, so we averaged the results of that treatments to compare with the control. This p-value that you are seeing here is the value of the contrast, is the p-value of the contrast. So for tasseling, and at the specific point that we went out and did the R1 sampling, we could detect that in control plots, about 40% of the plants were showing tassels, compared with the starter treatments that has about 90% of the plants showing tassels. So this is an image that is showing that result, and this is H3 in CPAC. So this, the central plot that is showing here that is greener, it will be a control plot versus starter plots that are showing a higher number of tassels per each plot. This indicates that, in fact, the starter did accelerate the plants to reach reproductive mature stages, so it takes less days to get to tasseling. And this result in tasseling can be related with grain moisture. We were able to detect a difference of about 1.6% in moisture of a control versus a starter, where the starter treatments show a drier grain. And for the yield, finally at CPAC, we were able to have a bigger difference. So the control was lower in yield for about 800 kilograms per hectare compared with the starter treatments. And that happened in CPAC, so we had a big magnitude in the differences for these three variables. In NIPAC, we did detect significant differences for tasseling, but at the point that we were measuring this variable in the field, I think that we were late in the reproductive stage time, so we only saw a difference that was not as big as we could see in CPAC. Again, with the moisture, we saw difference, but they were smaller than compared with CPAC difference. And in yield, only about 300 kilograms per hectare was the increase of yield for the starter treatments versus the control plots. But for 2019, the data that we have, the two treatments did show an increase in yield, even though this variable is the inconsistent variable when we talk about an effect of starter fertilizer in corn. So with that, I would like to give you my take-home messages and something that I hope you remember of this presentation. So the starter fertilizer that include potassium, phosphorus or potassium did not show any different from the one that had only nitrogen in all the variables that we measure across the season. In thinking and talking about crop development, we did detect that the starter fertilizer accelerates crop development and as a higher dry matter accumulation for a specific leaf number. In the case of nitrogen, the concentration was higher with the starter in earlier season, around before, but after that point, and remembering the application of the side dress was equivalent or lower to the control. For the case of phosphorus, we found the addition of phosphorus to the two starter treatments did not affect the concentration for the three different starter treatments. And in the case of control versus starter, this concentration decreased across the time, but was lower for starter fertilizer plots after B6. The content did not show difference, and that, as I said, was related with the offset by higher dry matter to the concentration. In the case of potassium, the concentration behaves the same across the season, and only we find only difference around B14, but these ones are due to less number of leaves in that point of the control plots. For tasseling, we did in fact detect that starter fertilizer decreased the time needed to retouch tasseling in our two fields. And in the case of yield, we found an increase in grain yield in the two fields, and a decrease in moisture. I would like to thank to Dr. Jim and Dr. Nielsen. They have been really nice advisors. The Jimbo team, all the girls that helped to collect all those samples across the last season and this season in all the fields, and the Purdue Ag Centers and all the workers that were willing to help us every time that we were in each field, and all the different entities for the funding support. With that, I would like to close the presentation, and if you have any question, I am more than happy to take that.
Okay, if you have questions for Daniela, unmute and let her know who it is that's talking, and then go ahead and ask your question. I guess I will start, Daniela.
Okay.
So I have questions just in case nobody else asks any. So my first question is, what was the? It's a kind of a two-part question. So the first part would be what were the soil types at the two fields between CPAC and NEPAC, and then the second part of that would be, did you take soil samples for fertility prior to and like what were the levels of P and K, and like were they adequate, and do you think that that's why you didn't see any differences?
So the fields were silty texture soil, or silt alone, if I'm not wrong, for both of them, but I will double check that. And in the case of soil samples, we did take soil samples early in the season before planting, meaning before the apply of fertilizer. And we found that phosphorus was close to in the two fields, was 54 and 53 in each one. and potassium was around 132 for the two fields. So the lower levels of both nutrients were adequate in the two fields. In the case of potassium, it was a little bit high, in the limit of high for the two fields. So yeah, maybe this was the level of the two nutrients could have been related to the lack of response to the different composition of a starter fertilizer, since we already have that much in the soil available for the plant. Yeah.
Okay. Other questions for Daniela? Because if not, I'll keep asking. Okay, my next question, Daniela, is so I guess I guess first my first question would be, what were the different sources for your fertilizer?
So we have four different liquid fertilizers. We have ammonium thiosulfate. Uh, we apply urea ammonium nitrate to, ammonium phosphate, and potassium thiosulfate. Those were the four that we mixed to get to all the different rates of each treatment.
Okay, so did you do any kind of did you look at anything as far as like what the cost of the different starter treatments would be to basically see if the increase in yield that you got that you saw at the end of the year um, would offset the cost of the starter fertilizer?
That application. I haven't checked prices, like how much is the practice, like the application process plus the value of each fertilizer. I haven't been able to do that. And since we are only doing this for like 1 year or 2 years, in my case, we haven't done that analysis. But I will think about it to see if we can have any kind of advantage in money wise to use a starter fertilizer. Yep.
Okay.
Thank you for your question. It's a good question. I will think about that. Okay. Yeah. Maybe some.
All right. Does
Yeah.
anybody else have questions for Daniela?
So yeah, answering your question, the turbine healthy. It doesn't say nitrogen is the same source that we are using in sidres, so it's not going to cost any more to apply it. And in the case of phosphorus, it's going to be just a few more dollars per acre. So if we count only that, and if we say that nitrogen is not, it is enhancing that response, probably we will have a response in money. So in money for the farmers. Yeah, if we only use the nitrogen. Yeah.
Makes sense. That makes sense. All right.
Hi, Daniela. I have a question.
Hey.
Sorry, this is Gordon.
How are you?
I'm well, thanks. How are you?
Good,
Great
good.
presentation.
Thank you.
I was wondering if in this next round of sampling and analysis, if you're also looking at residual effects of the nitrogen phosphorus in the soil, or multi-year effects of treating the same plots twice. Will you be comparing them across years as well?
We are, so you want to know if we have some residual effects from last year treatments.
Right.
So we do the soil sampling again every year to check the nitrogen, phosphorus, and potassium levels. And we try to, if we are doing the same treatments, we are trying to match the same treatments in the same plots year by year. But more than that, I think that we haven't done any analysis about a previous year compared with this year. And we are not analyzing years together. So we are keeping years separate for the data analysis. Yeah.
Okay. So the data then would be a cumulative value over years, not necessarily like a split plot with time as a subplot factor.
Yeah, so will be a
Okay.
complete separate analysis. Yeah.
Okay.
Okay. Thank you for your
Thanks.
question.
Did you do it? Did you do it on the same field both years?
Yeah, last year
Okay.
and this year. Yeah. Yep, we are still processing the data of this year. We will see what we got.
Other questions for Daniela? Okay. I think Daniela is getting off a little bit easy here compared to some of the people that we've had recently, but that's
I have
okay.
a question.
Okay.
Great.
So hi, Daniela. This is Lauren Schwartz. I just got a question about when you were applying your starter fertilizer, were you concerned, like what was your clean out process between each treatment as far as the nutrients went to make sure there wasn't any contamination?
Okay, so thank you for your question. You want to know if there was any type of cleaning to avoid contamination between the treatments. So what we did every time when we were mixing the treatments for each treatment, so was that we applied the first control, that was the small amount of nitrogen plus sulfur. And if we had the possibility of use different tanks in the farm, so you will have the first control in a different tank, and the first treatment that was only nitrogen in a second tank, and the third treatment that was nitrogen plus phosphorus in another tank. So that was how we separate the treatments in the mixing process. If we were not able to use different tanks, we were able to use that in NIPAC. We mix the treatments one by one. So we did first the control, we apply the control, we come back with the tank, check how much water we still have in tank to know how much fertilizer we have. Then we did calculations to know how much we have to add for nitrogen in that case. We apply the second treatment, and then we come back and add the phosphorus. We apply the third treatment, and we come back and apply the potassium. So that's how we try to avoid contamination between the plots due to the treatments.
Thank you.
Thank you.
All right. Does anybody else have questions for Daniela?
No, they don't want that.
Okay. If nobody has any further questions, let's give Daniela a virtual round of applause. Next week, we will be back at the same time with Chance Clark, who is going to actually give us his proposal presentation regarding branch architecture in soybeans. So the genetics behind the branch architecture in soybeans.
Hey, Richard.
Yes.
Actually, it's changed. It should be updated. It's going to be about microRNAs and drought response in soybeans.
Okay. Well, that's what it's going to be about from Chance himself. So please join us for that. Help Chance go through his proposal and ask him questions to help him move forward with his research. And again, thank you everybody for being here. Thank you, Daniela, for presenting. Nice job. And everybody, I hope have a good weekend.
Thank you all for coming to the presentation. Thank you.